Hi everyone, in this video we will study the effect of current carrying conductor in a magnetic field. Before we start our lesson, let's review our existing knowledge. Number 1, there are magnetic field lines in between permanent magnets with different poles. Number 2, there are magnetic field lines circulating CCC or current carrying conductor. So, there are two types of magnetic field lines in the magnet and in the current carrying conductor. What will happen when these two magnetic fields interact with each other? To answer this question, we will conduct an experiment to study the effect of current carrying conductor in a magnetic field.
Magnet kekal ini ada medan magnet. Kemudian di sini kita ada klip penyambung yang akan menyambungkan current carrying conductor kepada bateri atau nama dia sel. Ini ialah terminal negatif. Ini terminal positif. Apabila disambungkan, apa yang berlaku? Arus akan melalui konduktor. Okey, bila disambungkan, okey, tengok tu apa yang berlaku.
Seperti yang anda lihat, wire copper bergerak ke depan. Ini bermaksud arus bergerak dari positif ke negatif.
As you watch this video, I will explain further on this experiment. So, we have two copper rods and a copper wire without insulation, a pair of magnetdoor magnets and low voltage direct current supply. As the power supply is turned on, the current flows into the copper wire. The direction of current, I, is out of the plane. The direction of magnetic fields is from north to south. During this experiment, we can also determine the direction of copper wire based on Fleming's left-hand rule. The movement of copper wire is from left to right by our previous observation on the experiment.
Dan wire pun bergerak ke depan. Kalau mengikut hukum Fleming tangen kiri, ini mewakili daya, ini mewakili medan magnet dan ini mewakili arus. Medan magnet bergerak dari utara ke selatan, arus bergerak dari positif ke negatif dan daya bergerak dari yang terhasil wire kuprum bergerak ke hadapan.
For this explanation, the terminal of the battery has been changed. Current flow from positive battery to negative. For this diagram, the direction of current into the plane of the paper. Thus, we can determine the magnetic field of current carrying conductor by right-hand rule. And we can determine the magnetic field of magnetdoor magnet, which is south. But remember that there is interaction between the magnetic field of current carrying conductor and magnetic field of magnetour magnet known as catapult field. The catapult field exerts a resultant force on the conductor, thus the direction of force F can be determined by Fleming's left-hand rule. Therefore, for such setup as this experiment, the force acting on the conductor is from right to left. Now, to answer the first question in the beginning of this video, which asks what will happen when these two magnetic fields interact with each other, the interaction between the magnetic fields in the current carrying conductor and permanent magnets will produce a catapult field, which its direction can be determined by applying Fleming's left-hand rule. Fleming's left-hand rule of force on current carrying conductor can be determined by Fleming's left-hand rule, where F is the force acting on the conductor, B is the direction of magnetic field from north to south, and I is the direction of electric current. So F, B, and I, and they are perpendicular to each other.